So to do prime factorization, you pick any two pairs that multiply to give you the number above. This is like, they call it a factor tree, because you know how a tree like has roots that go into the ground?
Yeah.
These are like the roots.
Oh.
And so in the end of this problem, we want to write 24 as a product of all primes. So when she said she did 4 times 6, it's because this set of the beginning, like roots, so to speak, 6 times 4 makes 24. And if neither one of those numbers, 6 or 4, are prime, you keep like going deeper into the roots until the bottom of all the roots are prime. So the way I set this form up was kind of full of hints, right? Because it's telling you to keep going with these little root systems right here, right? That's a root system. So 6 breaks down to what, Eliza?
6 times 3.
Uh-huh. And so the next thing is, anytime you write a prime down, my habit is to circle it because I'm going to need it in the final answer. And then 4 breaks down to what, George?
2 and 2.
Uh-huh. That's right. So I circle all of those. Those are all the primes. And what that means is 24 can be written as 2 times 2 times 2 times 3. 24 can be written as a string of prime numbers. So the thing you would want to do is check your work. So also write it as exponents. So there is, in this over here, there's 3 2's. So we write that as 2 to the 4th. I mean, 2 to the 3rd power. Sorry about that. 2 to the power of 3 times 3. So to check your work, it's kind of like going backwards on order of operations. 2 to the power of 3 is 2 times 2 times 2 times 3. 2 times 2 is 4. Then you bring that 2 down. 4 times 2 is 8. And 8 times 3 is 24. So if you work out your answer, you should get back to where you started. So the prime factorization is just a way to write a number as a product, which means multiplication problem of all primes, and use exponents. So 2 to the 3rd times 3 is the prime factorization of 24. So Rio, 9 times what makes 63?
7.
Right, 7. And so since 7's prime, you circle it. That's just a reminder that you're going to use that number. Okay, Riley, what about what goes under the 9?
3 and 3.
3 and 3. Those are both prime. So the first step to getting my prime factorization is write my factors, my prime factors in order from low to high with multiplies, and then write them in exponent form. So what's the exponent form for that? Yeah, Haley?
3 to the power of 2.
Right, 3 to the power of 2
Times 7.
times 7. And again, if I wanted to check my work, I would just do 3 to the power of 2 times 7. 3 times 3 times 7. That's 9 times 7, which is 63. Okay. Thumbs up or thumbs down, guys? Brandon, what'd you put under the 48?
48, I put 8.
Good. And since neither 6 nor 8 are prime, we put roots under them. So what's under the 6?
Under the 6 is 2 and 3.
Correct. So 2's prime, 3's prime. This 2 that's already typed in there is prime. What goes in this blank?
4.
4. Ava, what goes next?
Then underneath the 4, you're going to do 2 times 2.
Right, and you notice how I didn't circle the 4 because it's not prime. I'm just going to circle the prime. So tell her, how many 2's do I have there?
4.
4. And are there any other primes? Anything besides 2 there?
3.
Uh-huh. So 8 in bold, how do you write that in exponent form? Without exponents, it's 2 times 2 times 2 times 2 times 3.
2 to the 4th power.
Right.
No,
Correct.
To the 4th. Yeah.
Oh, I thought you said 4. 2 to the 4th power, 2 to the power of 4 times 3. Do you see that, Aiden? There's 4 2's?
Yeah.
Okay. Let's have you practice one. So, why don't you try 200. Find the prime factorization of 200.
Oh, golly.
So this should be in your comp book. Right, these are your notes today. There's no note catcher for this. So these are your examples to take home for your assignment. Should have paused that. Okay, so what did you start with, Aiden?
I started with 102.
Okay, that will work. What we'll do is we'll look at more than one way. Fox, how did you start? Brooke, how did you start?
20 and 10.
Okay, we'll start with both. The idea is that I want you to see that as long as you start with a correct factor pair, it's always going to work. But the farther your number, your first factor pair is apart, the more like lopsided your root system is. So Zane, under 100, what will I have? What's one choice?
I put 50.
Okay, so 50 and 2. Should I be circling anything yet?
2. Yes.
The 2's, right? So are we finished? Kate, what can I do next?
50,
So you're going to work with the 50. So find a product of, okay, 10 and 5, sure. Are there any primes there, Kate? 5. Okay, 8 and Marie. Next.
2 and 5.
2 and 5. Any primes there?
2.
Okay. So when we look at the bottom of our tree, look at that. Wow, that's big. That is big. Since there's nothing, the lowest level of each root system has been circled. Do you see that? Like under every number there's something and everything's circled at the bottom of the roots. That means we've broken 200 down into all primes. Haley?
So basically you go until you see you can't put anything in the 5. Just go until you can't.
Well, until there's nothing but primes left at the bottom of the roots. So, for example, then what I would do is I would look at how many 2's I have. 1, 2, 3. So I would write that as 2 to the power of 3. And then I'd look at my other prime numbers. I have 2 5's. So that's times 5 to the power of 2. And then I would check my answer. But the way I'm going to check my answer is I'm going to do it a different way this time. Aiden and Eliza, questions? You
Why don't on it, why do you like do that equation, not like that?
Why am I'm this exponent thing?
Yeah.
It's because we're writing, do you remember? So let's put that other page in. What the prime factorization is a way to rewrite the number 200 as a product of all primes. So if I look at that and expand this, 2 times 2 times 2 times 5 times 5, This, we know we've been practicing 2 times 2 times 2 is 8. 8 times 5 is 40. And 40 times 5 is 200. So it works. We're rewriting the number in as a product of prime numbers using exponents. And you know, you use it just once in a while. Actually, you don't use this a lot, but once in a while you do. We're going to be using it for a puzzle activity today, so I just wanted to show it to you. So, Eliza, how would you start this one? Oh, what was your question?
For 50, why can't you do, when you do 25 times 2, it doesn't work?
It does. So we can see, look at that, and we'll find your mistake. 25 times 2 will work. Let's do this one first. 20 would be, say, 4 and 2 times 10. You want to do 2 times 10? That'll work. So 2's prime. And then 10 is 2 times 5. Both of those are prime.
At the 10.
And then I have to do another 2 times 5. And both of those are prime. So I still get the 3 2's, 2 times 2 times 2, times 5 times 5, which is 2 to the 3rd power, times 5 to the 2nd power. So Eliza's question is, what if we did 102, and then did 50 and 2, but then with the 50 did 25 and 2, but the 50 breaks down to 5 and 5. So there's your 3 2's, 2 times 2 times 2, and your 2 5's.
Okay.
Okay? That's prime factorization.